Hello and welcome to this nuclear reactor design tutorial video. In this video we will be covering the heat generation from fission. First we will do a small review on fission. Fission occurs through radioactive decay or through a nuclear reaction. When fission occurs, one nucleus splits into two smaller atoms while releasing neutrons, gamma rays, and energy. When this energy is released, it gets absorbed by the fuel and turned into heat. And by using this heat in nuclear power plants, we are able to create electricity. To show how to calculate the heat generated through fission, we are going to look at this example here. We have a cube of nuclear fuel that is undergoing irradiation. We want to figure out how much the temperature will increase over time. The data we need to know to solve this problem is first the flux, the macroscopic cross-section of the fuel, the specific heat of the material the fuel is made out of in the units of joules per kilogram Kelvin. We need to know the mass of the fuel. And finally, we need to know the average amount of energy released per fission in the units of megaelectron volts per fission. So now we will look at the same example question, but this time with the information we need. We have a 5 kilogram cube of nuclear fuel that is undergoing irradiation with a flux of 10 to the 14 and a macroscopic cross-section of 0.01 centimeters to the power of -1. Each fission releases an average of 200 megaelectron volts, and the fuel has a specific heat of 120 joules per kilogram Kelvin. The first step to solving this question is calculating the energy being released per second in the fuel. To do this, we can use this formula here, where energy released is equal to the flux times the macroscopic cross-section times the average energy released per fission. Now what we're doing here is calculating the reaction rate by multiplying the flux by the macroscopic cross-section. Now this will tell us how many fissions are occurring per second. Now by multiplying this by the average energy per fission, we will get a value of energy released per second. Now after plugging in the values from our question, we see that 2 to the power 15 megaelectron volts are being released per second. The next step we want to take is converting our energy that is in the units of megaelectron volts to joules. We can do this by multiplying our value by a conversion factor as shown here, and we can see that the value of energy being released is around 320.44 joules. So the energy being released per second is 320.44 joules per second. Now that we know how much energy is being released, we can calculate the increase in temperature. To do that, we can use this formula here, where heat is equal to mass times the specific heat times the difference in temperature. Now we want to rearrange this formula because we are solving for the difference in temperature. So after moving around some of the variables, the equation looks like this. Now all that's left is to plug in the values. 5 kilograms times 120 joules per kilogram Kelvin divided by the 320.44 joules per second. We see that the change in temperature is equal to 1.87242 degrees Kelvin per second. Looking at the amount of heat generated by fission is very useful, as it lets us know the rate at which heat must be taken away from the fuel to prevent a nuclear accident. This will wrap up this video tutorial. Thanks for watching.